Okay, last page. And took a few extra minutes to make sure I fully understood this page because I felt like I was kind of losing it on the other page. Okay, let's change the color. I guess purple is fine. If ABCD is a parallelogram, list everything you know about the sides and angles in the figures. Use specific names. Well, for one thing, we know that if it's a parallelogram, I'll write this smaller actually. All sides must be parallel to another. Okay. We know that opposite angles are congruent. Opposite, going off all sides must be parallel to another opposite. Sides are parallel. Opposite sides are also going to be congruent. What else do we know? What do we know about the diagonals? Diagonals bisect each other. Consecutive angles are supplementary. And there's one more thing. I'm going to write it over here. I'm just going to actually erase this because, well, that's fine. I'm going to say alternate interior angles are congruent. Okay. So let's start with opposite angles are congruent. Well, we have this angle and this angle. That was awful. This and this. So let's say angle BAD is congruent to BCD. What else do we have? We have this angle congruent to this angle. Angle ABC is congruent to angle ADC. Okay. Now, those are all the opposite angles we have. Opposite sides are parallel. Well, we have this side and this side. So AB, that was awful. AB is going to be parallel to DC. And then we have AD and BC. AD parallel to BC, was it? Yeah. Alrighty. Now, opposite sides are congruent. We can just use the same thing that we just did. So AB congruent to DC. AD, that looks like a P. AD congruent to BC. What do we have next? Change the color again to this gross yellow. Diagonals that was awful. Oh, okay. Diagonals bisect each other. So these bisect each other. That means that this can be congruent to that. So DE congruent to EB. And AE congruent to EC. That color is disgusting. I don't think I've used red. No. Consecutive and that's pink. That was there. Consecutive angles are supplementary. Well, that's going to be angle A to angle B. So we can say measure of angle A is plus measure of angle B is going to be equal to 180. What else do we have? B and C. Measure of angle B plus measure of angle C is equal to 180. We just keep going around the square, or whatever it is. Measure of angle C plus measure of angle T is equal to 180. And measure of angle D plus measure of angle A is equal to 180. Okay, we got those. What do we have? We have one more orange. Alternate interior angles are congruent. Well, what do we have alternate interior? That would be like this angle and this angle. That's angle BAE is congruent to angle ACD, because you have this. We could do BAC, I guess, and then this. Either one works, so that's ACD. Okay, what else do we have? We have this angle congruent to this angle. So that's ABD. ABD is congruent to angle CDB. Okay. We have this angle congruent to this angle, ADB. CBD. Remember, these are just our alternate interior angles. All right, we got one more. We have BCA. CAD. Okay, I'm gonna erase my picture. Do we have everything circled? We have 1, 2, 3. Yep. So I would just list out what you know to be a parallelogram. Opposite angles are congruent. Opposite sides are parallel. Opposite sides are congruent. The diagonals bisect each other. Consecutive angles are supplementary. And alternate interior angles are congruent. And then you just list all of those things out. It's pretty similar, just a little time consuming. You have to remember every single part, which could be hard. What color did I pick? Purple? Yeah. Alrighty, we don't have to do number 16. For each description of a quadrilateral below, say what special type of quadrilateral it could be. Quadrilateral is a hard word for me to say today. I don't know why. So my quadrilateral has 2 pairs of parallel sides. Well, that could be a parallelogram because I don't like how small this is. That would mean, if we look up here, that the opposite sides are parallel. What else could it be? Well, what are parallelograms, basically? We have rectangles, squares, and rhombuses. That one's pretty easy. Notice that it can't be a kite. Because these run into each other, these run into each other. Those could eventually run into each other. It also wouldn't be a trapezoid, because these will run into each other. There's not two pairs. My quadrilateral has perpendicular diagonals and two pairs of equal sides. Well, let's think about who has perpendicular diagonals. We have rhombus and kites and squares that have perpendicular diagonals. But if we only have two pairs of equal sides, as in not all sides, so not all, then we cross out the square and the rhombus, because square and rhombus have all four congruent sides. And then my quadrilateral has four congruent sides. Well, we just mentioned that a rhombus and square do not fit B because they have all congruent sides. So by that process of elimination, we answered this one. My quadrilateral has congruent diagonals. Well, this is one that we haven't really gone over today, but those include rectangles, squares, and isosceles trapezoids. If we look all the way back here, we did mention it here with equal, but I don't think I went into much detail and it hasn't come up since. But that is kind of like when I tried showing you that if they're equal sides and they're parallel, kind of. I didn't really show diagonals on that. But it is the same concept. If opposite sides are the same length, then the line connecting them has to be the same as well. Okay, fill in the blank with sometimes, always, or never to make each statement true. The diagonals of a parallelogram always, never, or sometimes bisect each other. This is always. They always bisect each other. I think I've mentioned this many times throughout the videos I made tonight. Also, my cat and dog are playing right now, so you might hear them. Okay. Opposite sides of a parallelogram will have different lengths. Well, what is one shape that we always talk about that we know is not a parallelogram? Because these two sides are different lengths. A trapezoid. So never is the answer to this one. Parallelograms are rectangles. Be careful with this one, because rectangles are parallelograms. But are all parallelograms rectangles? No. So this is just sometimes. Okay. I would make sure that you remember these formulas. If it's gonna let me highlight. It's not letting me do anything. Hold on. Okay. I don't know what's going on. Maybe my pencil died. Anyways, I would make sure that you know the distance and slope formula. So go over number 1. Definitely number 3. Know the differences between each shape. 5 and 6 are pretty good to know, but it's a lot of memorization. So just draw the pictures if you need to draw the pictures. Yeah, I think the pencil's dead. See if it works. That's okay. And then on this page, I think that you got this page down. Just if you remember these, okay. And just what parallelogram is. And number 3, that one will really help you down here. And just be careful with your math. Use a calculator. This last page, the first one, number 15, definitely remember all the things circled. Those are all very important. Know what a parallelogram is. This test is all about parallelograms, pretty much. Know what a parallelogram is. Be able to write out what a parallelogram is. And then just go from there and label everything you can. What are all the diagonals? What are all the alternate interior angles? And for 17, it's if I tell you to draw this shape, or if I tell you about this shape, what kind of shape is it? It's similar to, I think, one we did before. I think it was up here. Number 4, I think. Well, I don't know, it said give the most precise name. Oh, it was like number 1, but less. Number 1 was extra. So just think of what all the shapes it could be and then try to narrow it down. So parallelogram, name out all your parallelograms. If it said parallelogram with congruent angles, well, what are all your parallelograms? And then you have rhombus, you have square and rectangle, but you know a rhombus doesn't have congruent angles, so you cross that one out. So kind of use process of elimination on those. So I think that'll make it easier. And again, the always, never, sometimes. Just think of it backwards. Well, rectangles are parallelograms, but are all parallelograms rectangles? No. Only when it is rectangle, right? Just sometimes. And that's the same for like the 5 and 6. Read them backwards. Are all squares rectangles? No. Are all rectangles squares? No. But sometimes. Are all trapezoids isosceles trapezoid? No. Are all isosceles trapezoids trapezoids? Well, kind of, yeah. But it's more precise. Just take your time. Really focus on what you're trying to read. Draw it out. And hopefully these videos helped you. It's 8:30 now. I took Ryder out in between, so I'm going to say until 8:15 was the time span. Oh, my pencil works now. I didn't even notice. You got this. You're going to get a B for sure. Okay? Just take your time.